What's up, quarantines? Week 5 intro here for you. Talk about what we're going to cover this week, about what the weekly schedule should be, and then just try to answer a few questions that I saw coming up in the comments. I actually posted a reply back at the end Saturday morning. So if you haven't looked at that yet, maybe go back and take a look at my comments at the end of the discussion for week 4. See if we can clarify some of this stuff with the ideal gas law and where some of these values are coming from. So let's jump on into it here. All right, so what we want to do this week is analyze given problems or scenarios and make sure that you can figure out which gas law is best to use. Make sure that you are able to apply the right gas law to solve for an unknown, which you guys have been doing a pretty good job with that. Pay attention to the details. Make sure that, again, you aren't replacing the P, V, N, and T variables with X for some reason. I know that's more comfortable. You're used to solving for X in math, but these variables have designations, so stick with those. I want you to understand why temperature has to be given in Kelvin for the gas law calculations, and then correctly apply the equation-based problem-solving process to solve for the unknowns, meaning write down your unknowns, use that to figure out what gas law, rearrange the equation, plug it in, solve, and that's the process you should be going through every time, keeping units and everything. This week, all the laws that we've covered so far are going to be in place. You're going to have Boyle's, Charles, Gay-Lussac, the combined, and the ideal gas law. So you're going to have to work through a little bit of identification. You don't have to memorize everything. I'm going to show you that Boyle's, Charles, Gay-Lussac are all combined in the combined gas law. So there's an easier way to remember those ones. And then you can also write them down too. Just have a note card or a sheet of paper that has Boyle's law, statement, and equation, Charles' law, statement, equation, all those. Write down your R values on there. Make sure you have everything in one spot so that when you go to do these problems, you're just looking at a reference, okay? So this week's going to be a little bit different. We only have 2 graded activities this week. Hopefully you're watching this on Monday. Once you get done with this, in the assignment post, there'll be a choose the right gas law activity. It's an expanded version of what we did a couple weeks ago. I want you to go through there and see if you can, just after this video, identify which of those problems in the form do you need Boyle's law for, Charles, Gay-Lussac, combined, ideal. It's not graded. It's there for you to take as many times as you want to improve your proficiency. I think I can set it up to shuffle around the questions so they're not always in the same order. So I'll make sure that that's done too. So watch the intro video, do that, choose right gas law form, hopefully Monday. Tuesday, there's a step-by-step ideal gas law video that I'm going to post where I go through a problem and explain some of the details for the ideal gas law problems. Tyler DeWitt had the video. I hope you guys watched that. If you didn't, please go ahead and do that as well. But I'm going to go through a problem with you using the 6 steps, show you step-by-step what to do, how to pick the right R value, all that stuff. Wednesday, you should begin working on a practice problem set. This is going to be one of the graded activities this week. You're going to turn in electronically. If you can scan the document with and send it as a PDF, it's a little bit easier for me to review than those of you guys that are just taking pictures. There's an app called Cam Scanner that works really well, really easy to use, and gives really clear images of your work that I can actually go and comment on a little bit better. Some of y'all that are sending me the pictures, it's a little tricky, but if that's too challenging, just keep doing what you're doing. A lot of you guys that are using the Cam Scanner or the PDF, thanks for doing that. That's making it easier for me to check your work and get it back to you quickly. On Thursday, I want you to try to finish up that practice problem set so that you can get that done before the end of the week, so that's not hanging over your head over the weekend. You have until Monday, the 18th at 11:59 p.m., so basically before midnight on Monday the 18th. But the more that I'm seeing you guys that are doing the work over the weekend or on Monday, you guys just aren't performing as well as those of you that are getting them done earlier, because I think it's fresh in your mind. You're not losing anything over the weekend. So try to get as much done of those problem sets as you can before the weekend and get those turned in. I'll put a practice assessment up for Thursday as well. Probably post the assessment Thursday. So if you want to get that done before the weekend, you'll have time. If you didn't start the assessment before Friday, please go ahead and do that. Again, remember the test and the practice problem set electronically submitted are due by 11:59 p.m. on Monday, May 18th. So just some things to consider for this week. If you look at this equation, hopefully we recognize that as the combined gas law. So let's say we are in a situation where you're given two different pressures, you're given one volume and asked to find a second volume. Temperature is not mentioned at all, or maybe they tell you that temperature is constant. Well, then cover that up. Just imagine putting a piece of paper over the T's so that they go away. Well, then what's above the line? P1 V1 equals P2 V2. That's Boyle's law, right? So Boyle's law is in the combined gas law if you just ignore the T's. Well, what if they give you volumes and temperatures, but they don't say anything about pressure, or maybe they tell you pressure is constant? Well, then the P's are gone. Ignore the P's. What do we have? V1 over T1 equals V2 over T2. There's Charles' law. What if the volumes are constant, or they don't give you volumes? They only talk about temperature and pressure. Well, then that's P over T equals P2 over T2. That's Gay-Lussac. So Boyle's, Charles, and Gay-Lussac are all in this one equation. Just cover up the portion that you don't need, okay? Again, you can write down all four of those gas laws and label them. You can write the statements down for them as far as inverse and direct proportionality. I'm just trying to give you a way to get this in your head so you're a little bit faster at doing this. If you only have one set of data, or they mention moles, only one set of data, or they mention moles, you're going to use the ideal gas law, PV equals nRT. And just so we can clarify what this R value is, there's a lot of you folks in the discussion that were saying how adding in R was making this confusing. It's actually cutting down on the number of variables. So if we need to relate all four items together, we end up with this PV over NT equals P2 V2 over N2 T2. That's 8 variables to keep track of. If we put in standard pressure, volume, mole, and temperature, so let's just use atmospheres. 1 atmosphere, 22.4 liters, 1 mole, and 273 K. And guess what? We get that 0.0821 ATM liters over mole K. You plug 0.0821 in, and there's that weird unit that's like a fraction, but that's just so that you can cancel everything out over here with the given pressure, volume, temperature, and moles. Those are just to cancel units so that you can make sure that you have the right unit, to make sure that the pressure over here, if this is 0.0821 ATM liters over mole K, that you make sure your pressure over here is in atmospheres. Make sure that all your units match with the R. Volume's got to be in liters. Temperature has to be in Kelvin. Pressure that matters. And then amount's always going to be in moles. So if your pressure's in kPa, you're not going to use 0.0821. If the given pressure's in kPa, you're going to use the 8.314 value for R. Or you can change the kPa's into atmospheres, just doing a quick conversion. That'll be in the second video. I put that in there for you. And the reason we have to turn temperature into Kelvin is because of the relationships themselves. Temperature, pressure, temperature, volume relationships only work with Kelvin. If you think about what would happen to the numbers After we get past 0 Celsius, we end up with -1, -2, -3, -4, -5. If we used Celsius, our curve, if we were going to graph that, would almost have to look like a parabola. We don't want that. We want a linear, straight, consistent relationship. If we use the idea of 0 Kelvin being the lowest possible temperature possible, -273 Celsius is 0 Kelvin, then we get a perfectly straight line relationship. It's not that hard of an adjustment to make. Just please remember, before you plug anything in for T in one of these equations, Boyles-Charles, Gay-Lussac, combined, ideal, you have to change it to Kelvin. It's the only way the relationships work. Now, this week, the load's a little bit lighter because we're getting ready to roll into AP testing these next 2 weeks. So if you have some AP tests, please touch base with me if there's any conflicts or you're getting jammed up towards the end of the week because of those AP tests. Just let me know and we'll make some arrangements, but you have to let me know. Don't use that as an excuse after the fact. If you know your load's heavy this week or next week with testing, then touch base. I want to help you out. I want to make sure that you're able to focus on those things to get the highest scores that you can. The practice problem set, we're going to turn that in electronically through Google Classroom. Weekly assessment, like normal, Google form. Make sure you fill it out and submit it. And that weekly assessment, some of you guys aren't scoring real well. Take your time, go back and check the notes. If you're not 100% certain on these questions and the answers, folks, you have the capability and the permission to go back and look at your notes. Don't just take a wild guess at these answers. Like, everybody should be getting at least you should be getting a B on these. Hopefully everybody's getting A's. It's open note, open book, open video. Like, do what you got to do to find the answers. This is just a way for you guys to earn some points and to make sure that you're learning the content as we go. As always, email me, post questions in the Q&A weekly thread. There'll be one for week 5. You can send a private message through Classroom. And if we have a group of you that are still struggling with some stuff, we can try to do something virtually and try to help you out if these videos aren't cutting it. Last thing is make sure you get your work done before the posted deadlines. You got to meet the deadlines. And if you're not going to meet a deadline, I need you to touch base with me before the due date is passed. So this week you have 2 things that are due. 2 things that are due this week. You have your practice problem set. I highly suggest you get that done and submitted by Friday afternoon. That way you have the rest of the week, the weekend into Monday, to focus on the test. I would suggest trying to get the test done before the weekend as well. When you guys let things go over the weekend, as good as your intentions are, is to get things done, sometimes that is to your own detriment. You forget things that you've worked on through the week. And if you guys aren't looking at this video until Wednesday, Thursday, you guys need to maybe back up a little bit and make sure that you're checking in Mondays to make sure you understand what's going on for the week. Because as we move forward, the progression might change and the due dates might change a little bit. So keep an eye on that, okay? Last thing before we cut out here, if you just search Tyler DeWitt gas laws, and I'll actually link this in the comments below here for the assignment. Here are all of Tyler DeWitt's gas law videos, and there's even one down here that explains R. So for some of you guys that are still struggling with that R idea, the ideal gas law constant, there's rearranging the different gas laws. There's all kinds of resources on here, not just Tyler DeWitt. I mean, Bozeman Science is a good one. Professor Dave, Marissa Maribel, or just shoot me questions and I'll try to address them in a midweek video if that's necessary. Stay strong, guys. We're almost at the end. Enjoy the fact that we're back to some semblance of moving forward. We're in the yellow, which is good. Maybe we'll be in some shade of green that'll give us some freedom here pretty soon. Do something to make yourself better every day. So stay strong, be healthy, improve daily. See y'all.